For this mini lesson, we are solving absolute value inequalities. This will be a longer video because we have to go through multiple options that you might see when it comes to absolute value inequalities. I went ahead and I included this little notes section that breaks down how-to steps, two of the types that we're going to see, which is an and sentence versus an or sentence. And I've included the special cases, which is when we have a no solution, also known as the empty set, or when we have a solution that is all real numbers, which can be indicated by the all real numbers symbol. If you need to pause the video to look more in depth on what I have screenshotted into this, please do so, but I'm going to start going through our first example. So when we are solving absolute value inequalities, our job is to first isolate the absolute value. I like to use a highlighter to indicate what I am isolating so I don't get confused. So starting to isolate that, I'm going to put my inequality sign line up. And if you remember from previous videos, every time we cross that line, we have to do inverse operations. So the first inverse operation we are going to do is we need to get rid of this positive 8. The opposite of that is to subtract it. So I'm going to subtract that 8 to the other side. Keeping things nice and organized, I'm going to drop down my 5, the absolute value of x minus 5. 8 minus 8 will give me a 0, so that's gone. Again, that's the purpose of the inverse operations. Dropping down my inequality symbol, and then 48 minus 8 will give me 40. Once again, I'm going to highlight my absolute value because that is what I'm trying to isolate first. I see that right now there's a multiplying 5 on the outside. We need to do the inverse of that, which is dividing. So I'm going to divide by 5 and divide by 5. Now 5 over 5 becomes a 1. Notice we do not touch what's inside of the absolute values. What is inside of the absolute value is protected. We do not touch that. So that part will drop down as is. Absolute value of x minus 5. Now, we did not multiply or divide by a negative, so our inequality symbol will remain the same. And then 40 divided 5 becomes 8. Now, here, notice our absolute value is finally isolated on this side of our inequality. There's nothing in front, there's nothing behind it, so this is where we can split our answer or our question into the two cases. So for the two cases here, we are going to have our positive case, which essentially means it's going to stay the exact same, just no more absolute value. So we have x minus 5 less than or equal to 8. For our negative side, we use the acronym KFC, which represents the keep, flip, change, which I have right here in the notes. What this means is we are going to keep the absolute value stuff the same, just no more absolute value. We're going to flip the inequality to face the opposite direction. So it was a less than or equal to symbol. Now we're going to change it to be a greater than or equal to symbol. And then the change part is we're going to multiply everything that was on the other side of the inequality with a negative 1. So I'm going to do negative 1, and then in this example, it happens to be just an 8. Once we have both the positive and the negative case set up, we are now good to solve these out. So I'm going to go ahead and zoom in on these. Starting on this positive side, I'm going to put my inequality sign line up. We need to get x alone, so we need to move this negative 5 by doing the inverse, which is adding 5. We're going to drop down that x. Negative 5 plus 5 becomes 0, so that's gone. And then keeping our inequality the same. And then we have 8 plus 5, which will give us 13. And then this is actually our first solution. So we're going to leave that there, and let's solve out the negative case. So again, starting with that the inequality sign line, I'm going to go ahead and drop down our x minus 5 and the inequality symbol. Then I'm going to multiply negative 1 to 8 to get negative 8. Now doing our inverse operations, we need to move that negative 5 to the other side by doing the opposite. So we're going to add that 5 over. Dropping down that x, negative 5 plus 5 will give me 0. And then dropping down the inequality, -8 plus 5 will give us -3. Now, once we have our two solutions, it is very important that we put this in order with the smallest one going first and then the largest one going second. And when I'm talking about smallest and largest, I'm indicating the number that we've got. So -3 is smaller than 13. So when I go to rewrite this, I want to put that one first. So x is greater than or equal to -3. Then I'm going to put the x is less than or equal to 13 second. And again, it was all based on the numbers as how I knew what order to put them in. Once I have them in order, I'm going to zoom back out now. This is where we are going to look for what case we're dealing with. So if our inequality symbols are essentially facing each other, sorry, let me use a lighter color. If our inequalities are facing each other, boop, like so, then this is what I call an and sentence. And when I say an and sentence, it's because it's one continuous shading in the middle of the graph, and it will become one sentence for our final answer. So I tried my best to essentially create a formula for us on how to write this sentence. So we will start with our small number, and then we will do our inequality less than or equal to x, less than or equal to x, and then our big number. So that is how we want to set up our answer here. So going back over here, to set up this answer, I'm going to do my small number first, -3. Then I'm going to put my less than or equal to x, and then less than or equal to, and then the big number, which is 13. So this is the official answer in algebra. Now to graph this answer, and I know I'm definitely running out of space, we are going to just claim this as my -3 and here as my 13. And then because we are dealing with the or equal to's, so again, if I zoom out a little bit again, if we have or equal to, so less than or equal to, greater than or equal to, we are going to use a closed dot because it does not include the number. So on my number line, I'm going to do nice big closed dots. And again, this means that we are including that number in the set. And then because it was an and sentence, that means the shading will be in the middle of those two dots. So then this will be our official graphed answer on a linear, or on a number line, excuse me. Okay, I will zoom out on that one. Now we are going to go ahead and repeat this type of question so we can see another version. So I'm going to zoom in now on example 2. So I'm going to start it the same way. The process is we need to isolate what is in the absolute value first so we can break that absolute value. So I'm going to put up my equal sign line. And remember, anytime we cross the equal sign line, we need to do inverse operations. Starting with this -4, I'm going to add that 4 to the other side. Going to go ahead and drop down my 3, drop down the absolute value of x plus 4. That -4 plus 4 becomes 0, so it is gone. And then 20 plus 4 will give me 24. Once again, I'm going to highlight the absolute value because that is what we are trying to isolate. There is still a 3 in front of it that's being multiplied. We need to do the opposite, which is dividing. 3 over 3 becomes that 1. Again, notice we do not divide what's inside the absolute value. What's inside the absolute value is protected. So I'm going to drop down my x plus 4. Going to drop down my inequality. And then 24 divide 3 is 8. And then once again, I'm going to highlight the absolute value because that is what we are trying to isolate. Now, at this moment, our absolute value is isolated. There's nothing in front, nothing behind on that side of our inequality, meaning we are now good to split this into the two cases. So first we have our positive case. Positive case, everything stays the same, just no more absolute value. So we have x plus 4, the inequality greater than, and then 8. On the negative side, we have our KFC, keep, flip, change. We keep the absolute value stuff, so x plus 4, just no more absolute value. We flip the inequality to go the other direction. So originally it was a greater than, now we're going to flip it to be a less than. Then we're going to change whatever is on the right side by multiplying a -1 to it. So -1 times, and in this case it's just an 8 over there. Once we have both cases set up, we are now good to start simplifying these or solving these. Starting on my positive case, I'm going to put my equal sign line up. We need to get x alone, so I got to get rid of this plus 4 by doing the inverse, which is subtracting 4. Dropping down our x, 4 minus 4 is 0, so that is gone. And then 8 minus 4 is 4. So here is essentially our first solution. Going to the other side to do the same thing, I'm going to put up my equal sign line. We need to start by distributing this -1, so 8 times -1 is -8. Then I'm going to just drop down everything on the left side along with the inequality so we have a new line of work. Now we're trying to get x alone, so we need to move this positive 4 over by subtracting it. And then let's go ahead and simplify, dropping down that x. 4 minus 4 is 0. Dropping down the inequality, and then -8 minus 4 will give us a -12. Now, just like last time, it's important that we put our two solutions in order. And again, we have to look at the numbers and put the smaller number first and then the bigger number. So in this one, -12 is our smaller number. So I'm going to put that answer first, which is x is less than -12. Then I'm going to put my larger answer, which is x is greater than 4, second. Again, when I'm talking about smaller and larger, I'm talking about the number values. -12 is smaller than 4. Once I have these set up, we can look at these and figure out what type of answer we're dealing with. So we have a less than symbol, then the greater than symbol. So as I zoom out to look at our notes, when we have a less than symbol and a greater than symbol second, we are looking at what I call my or sentences. This is because our graph is split into what I say is this or that. So there's a gap in the middle. And then just like last time, I have created what I am calling a formula on how we can write these answers. For the or sentence, it's really nice. Once you have them in order, you can actually just put the word or in the middle, and then you're good to go. So this one, in my opinion, is a little bit easier. So here's an example of a solution already written out. Notice they have the two answers with just the word or in the middle, and then you're good to go. So going down to what we have written, we have our two answers. I'm going to just stick the word or in the middle. This is our algebraic answer. Now we're going to graph this on a number line. Now it's a blank number line, so I'm going to just claim this as my -12. I'm going to claim here to be 4. Then we need to figure out if we are doing open dots or closed dots. Notice that because there's no line underneath the inequalities, these are not or equal to's. Okay, this is just a regular less than, this is just a greater than, meaning we are going to have open dots. So make sure those open dots are nice and obvious that they are open dots. Now because this is an or sentence, this means the shading will be on the outside of these dots. So my first shading will be going all the way to the left, and again, this is because it is a less than symbol, left for less than. And then my 4 is a greater than symbol, so we want to go up in numbers, shading it all the way to the right. And then that is our algebraic answer, and then this is our answer on a number line. Alrighty, we have one more example to go through. So for this last example, we're going to start it the same way. I'm going to start by highlighting the absolute value because that is what we need to isolate first. I'm going to put up my inequality sign line so we can make sure we do our inverse operations when we cross that line. So the first thing we need to move to be able to isolate our absolute value is we need to move this -3. The opposite of that is by adding 3. So I'm going to add 3 over, drop down the 2, drop down the absolute value of x plus 8. -3 plus 3 will be 0, so that is gone. And then dropping down the inequality. And then negative 6 plus 3 will be a negative 3. Once again, I'm going to highlight my absolute value because this is what we were trying to isolate. I still have a 2 in front of this, so we need to divide by that 2 because right now it says multiply. And then again, what I do to one side will do to the other. From here, the 2 over 2 becomes a gigantic 1. Remember, we do not multiply or divide into the absolute value. It is protected. So I'm going to just drop that down. Dropping down our inequality, and then negative 3 over 2 does not reduce, so we will just leave it as negative 3 over 2. Once again, I'm going to highlight my absolute value, and we are going to verify that it is now isolated. There's nothing in front, nothing behind, so our absolute value is isolated. Now, on this question, something really important is happening right now, which we need to recognize. Once we have our absolute value isolated, if what is on the other side is a negative, so here it is negative 3 over 2, then we must stop our math, okay? This is going to be a special case. So we are going to stop here, and the reason we are stopping is the isolated absolute value is, and I'm going to put the symbols less than or greater than a negative number. So that is why we are stopping. Now, when we are stopped like this, it is a special case. So, special case. And let's look at the notes to see what type of special case we're dealing with. We are looking at a greater than negative number. So we're looking at a greater than negative number. So going to our notes, here's where I'm talking about these special cases. If we are greater than a negative number, right here, greater than negative number, this means our answer will be all real numbers. The reason why, and I wrote it out, since the absolute value of any number is either 0 or positive, it makes sense that it must always be greater than any negative number. Because I could put any number on the left side, it will always be greater than the negative number because an absolute value will always result in a positive number. So here, boop, with this special case, we are done because we actually know our answer is all real numbers. That is our answer. If we were to graph this on a number line, because I did forget to draw a number line here, boop. If we were to graph this on a number line, we're going to just literally shade the entire number line. So if our answer is all real numbers, boop, 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 we can just shade the entire thing and indicate it goes forever to the left and forever to the right with those arrows. All right, I know this was a bit of a longer video, but we went through all of the types of answers you might run into, with the exception of the other special case, which is if we have an absolute value isolated to a less than a negative number, which would mean the empty set or no solution. So besides that, we have seen every case possible. Thank you so much.